Welcome to a session on types of optical fiber. Based on the mode of propagation, fibers are classified as a single mode optical fiber and multimode optical fiber. Based on variation in the core of refractive index, optical fibers are divided into two types: step index optical fibers and graded index optical fibers. Based on material, fibers are classified as plastic optical fibers and glass optical fibers. Based on mode of propagation, fibers are classified into single mode optical fiber and multimode optical fiber. Now let us see the concept of mode. Light launched into the fiber within the acceptance cone propagate through it by total internal reflection. But only light which travel through the fiber in a particular direction are allowed, which satisfies the condition of constructive interference. The light rays traveling in these specified directions are called as modes in optical fibers. Let us see the concept of single mode and multimode fibers. If the thickness of the fiber is small and that it supports only one mode, then the fiber is called as monomode or single mode fiber. For example, this one. Here the thickness of the, which means the core diameter is very small. That's why it allows only one mode of propagation. So this is called a single mode optical fiber. If the fiber supports more than one mode, and then it is called as multimode fiber. So relatively, multimode optical fiber have higher dimensions of core and cladding when compared to single mode optical fiber. So it allows to pass more number of modes of light through the core medium. So that's why it is called as multimode. So finally, it allows more than one mode of propagation from one end to the other end at a time. That means simultaneously it allows more than one mode of propagation. This is called as multimode optical fiber. Let us distinguish single mode from multimode optical fiber. Single mode has a small core diameter, as we discussed. It is around 2 to 8 micrometers only, whereas multimode has large core diameter. It's around 50 micrometers and can support only one mode of propagation, single mode fiber, and it can support more than one mode of propagation, multimode. Launching of light ray into the fiber is difficult in case of single mode fiber, and launching of light into the fiber is easy process in multimode optical fiber because of the diameter of the core. Fiber can carry information to longer distances since dispersion of signal is less. So in single mode optical fiber, the dispersion losses are less. Fiber can carry information to short distance only since the dispersion of signal is more in case of multimode optical fiber. Let us discuss something about step index and graded index optical fibers. Let us discuss step index optical fiber. In these fibers, the refractive index of core is uniform and is slightly more than that of the cladding. So, intermodal dispersion or pulse broadening occurs in case of step index optical fiber. If you take the core of the step index optical fiber throughout the diameter of the core, the refractive index is safe inside the core of the step index optical fiber. But if you look at the graded index optical fiber, in graded index multimode optical fiber, the refractive index of core varies radially. It has maximum refractive index at its center, which gradually decreases with increase of radius. At the core cladding interface, the refractive index of core and cladding are the same, almost near to each other. Pulse broadening is overcome in graded index optical fiber. This is the advantage of the optical fiber, graded index optical fiber. Here you can see. Here I can distinguish a step index. Here in step index optical fiber, let this white part is core. Throughout the core, along at this point or this point, this point, this point, this point, at any point throughout the diameter of the core, the refractive index is the same. But in case of this graded index optical fiber, at the center of this white part, which is called as core. Okay, so this green line, straight green line, indicates the direction of the axis of the core. Along the direction it is having maximum refractive index, but when we are moving away from this particular axis of the fiber, either upward direction or downward direction, this is called as radially outwards. So as you are moving away from the center, the refractive index goes on decreases either in upward direction or in downward direction. This is the case of multimode optical fiber. So this is the multimode step index optical fiber. This is the multimode graded index optical fiber. So here multimode step index, propagation of light rays in multimode step index. So once again, step index optical fibers are classified as two types. One is SMSI and another one is MMSI. SMSI means a single mode step index optical fiber, only allows one mode of light ray. This is actually multimode step index optical fiber, MMSI. So multimode step index optical fiber, which allows more than one mode of light at a time. So this is the graded index. By default, graded index is multimode. So there is no concept of single mode graded index optical fiber. By default, graded index optical fiber is multimode, MMGI, multimode graded index optical fiber. So this is the ray propagation inside the multimode graded index optical fiber. Let us discuss the transmission of a signal in step index optical fiber. Let a pulse travel through the step index multimode fiber. So this is the multimode fiber. Let us assume a pulse is traveling through this multimode fiber. The pulsed signal travels in different paths via path 1 and path 2. So this pulse is traveling inside the optical fiber in two paths. One is path 1. Path 1 means this is the straight line. This straight line is path 1. And path 2 is this dark line. So this is the path 2. At the receiving end of this is the receiving end. At the receiving end of the ray, traveling along path 1, reach first because it is traveling less distance. The ray traveling along path 2, this reaches after some time delay. So hence, the pulsed signal received at the destination is broadened and is called as intermodal dispersion. So, actual signal is this one. Finally, after passing through this multimode step index optical fiber, we receive this type of signal with output broadened. This is called as input and output are not same. Output is somewhat distorted from the input. So, we are not getting the original information. This is called as intermodal dispersion. Intermodal dispersion can be overcome by using graded index optical fiber. Let a signal pulse travel in two different paths in 1 and 2. For example, this is the straight line is path 1, and let us choose this uppermost curve represents path 2. The pulse traveling along path 1 travels less distance but in a medium of higher refractive index. Here you can see it is traveling from one end to the another end through a straight line, which is less distance, but in the graded index optical fiber, this minimum, this at the core interface, actually along the axis of the core, the refractive index is very high. So this straight line path is less distance path but more refractive index, whereas this curved path is traveling, the ray which is traveling along this curved path traveling more distance but it is less refractive index. Hence both the pulses reach the destination at the same time and the pulse broadening is overcome. This is the advantage of graded index optical fiber over uh, that particular single mode optical fiber, step index optical fiber. Meridional rays and skew rays. A ray that propagates through the core of a fiber undergoing total internal reflection is called as meridional ray. A meridional ray always crosses the fiber axis. Here you see these are called as meridional rays. Meridional rays crosses the axis of optical fiber always. Skew rays describe angular helical path as they travel along the fiber. A skew ray does not cross the fiber axis. Here you can see skew rays describes the angular helical path as they travel along the fiber. Here you see. So they travel along the helical paths and they do not cross the axis. They don't cross the axis of the optical fiber. This is the actual propagation, you can see. So the light ray propagates like this. It does not cross the axis. Rather than that, so it go in a path, spiral around the axis, but it does not touch the axis. These rays are called as skew rays. Let us distinguish between step index and graded index optical fiber. Refractive index of core is uniform throughout except at one stage in case of step index. Graded index. Refractive index varies gradually with radial distance in case of graded index optical fiber. Single and multimode propagations exist in case of step index, but there is no concept of single mode. Only multimode is there in graded index. Used for short distance application, whereas graded index optical fiber is used for long distance applications. Attenuation losses are of the order of 100 decibels per kilometer in case of step index. Attenuation losses are the order of 10 dB per kilometer in case of graded index, which means less attenuation losses are there in graded index optical fiber. Meridional rays propagation takes place and skew rays propagation takes place, which means that the path followed by the light ray in case of step index is approximation of meridian rays, and the path followed by the light rays in graded index optical fiber is approximation of skew rays.